Good morning, everyone, and welcome to a early edition of The Context. I am Shannon Williams, and here with my co-host Darren Shepard. Super excited to have you all with us today. The this is an exciting episode of The Context because there's loads of news going on in MCP land. We have been inundated with announcements and releases over the course of this week. Literally since we talked on Tuesday with the team from MCP UI and MCP Apps, we've had big announcements. Most excitingly, the introduction of the Agentic AI Foundation as part of the Linux Foundation, which is the new home for MCP. So MCP was donated along with Goose and Agents MD, and 50 companies have joined the MCP, this new Agentic AI Foundation. And we are something I think all of us who've been working with MCP since its early days were hoping would eventually happen has happened. We've now got the long-term confidence that this project and this, specifically this protocol is going to live under in a very open way. And luckily, I think, this shouldn't mean much of a change for anybody who uses MCP because honestly, the way that the team at Anthropic ran the project has been so open from the beginning and been so welcoming of anyone else who wanted to get involved that I don't think there's anything that's changing. In fact, that was a key message last night. There was the MCP night event hosted by WorkOS in San Francisco, and there was a big panel with all of the key contributors of projects to this new foundation. And I think the message over and over again was like, well, not a lot's really changing, but we are making a long-term commitment that this is not just open source software, but the project is going to have open governance. It's going to be part of the LF. So I was super thrilled. I think a lot of people were excited about this. It's definitely a big moment, in my opinion, because it does bring a lot of organizations together behind it. The word on the street is they limited the number of platinum members who could join this foundation initially. So, you have kind of the people you would expect, right? It's Anthropic and OpenAI and Block. Bloomberg was one of the members, but AWS, Microsoft, Google are all sort of other key members that joined early on. So but they limited it to 8. And I was talking to some LF people and they were saying there was like another 20 organizations who would have really wanted to sign up at this level. And to be a platinum member, you've got to commit about $700,000 of investment into the foundation. It's like $350K for 2 years. And I thought that was amazing. I was like, wow, that's how much enthusiasm there is really for this space, for MCPs, among the largest companies in the world who want to see it succeed and want to invest in it. So really cool, big night for everyone who's worked on the MCP. And, I think it's worth one more time really congratulating Anthropic on doing something in the open like this and seeing it flow all the way through. For our part, we are excited to join and be a member. I know our little company Obot is, but we also donated the MCP Dev Summit. So the MCP Dev Summit, which we ran last year in San Francisco and in London, will now be the official event for the foundation. And the first one that's run by the Linux Foundation is happening April 2nd and 3rd in New York. It's live now. You can submit your proposals. We have an amazing program committee that are going to be reviewing them all and putting together a world-class event. And for the LF, they are super excited about this. And their view is this MCP Dev Summit is going to be, their version of the KubeCon for the world around AI. They think that this layer is sort of so instrumental in how it's going to grow that they're just really big believers. So I'm super excited to see this. I think they started selling sponsorships yesterday, and they may have already sold them all. I don't know. Like the word I heard at MCP night last night was they were literally going that fast, that people were on the phone with the LF trying to sign up because there weren't enough. We obviously didn't book a big enough venue for the LF when we booked the Marriott Marquis in New York. So if you do want to sponsor and you watch the context, man, jump on it today. Do not miss out because I don't think there will be sponsorships left in a week. And more importantly, if you're excited about the space and you've got something you want to show, please submit a proposal to talk. We're going to be reviewing all of these, and it is a pretty fast turnaround. I think we only have about an 8-week window to review talks. So because the LF needs a little more time than we historically needed, the final date, I want to say, is like January 16th. I'll certainly update that by the next time and put it on the slide. But submitting your talks, it's open now. Submit early. We will all be reviewing them. There's 7 of us, a whole bunch of great people, a lot of people who've been on the context before, people like Tadas from Pulse MCP, Angie from Block, Erica at Alpic are on there, Den Delamarsky from Microsoft are on the panel. It's going to be, I think it's going to be a lot of fun, and I'm very excited to still be involved in trying to figure out the right slots to make this feel like a great educational event for our community. If you're not familiar kind of with the way these talks work, though, they are really meant to be very high level, very technical. So, think about the tracks that we've opened up. Oh, it is on my slides. January 22nd. That's the deadline. But I was just gonna say, there's a sort of a protocols in depth track. There's an MCP best practices track, and there's kind of a security and ops track. So as you're thinking about your talks, try and figure out the right place to put them. All right, with that, the context has been growing like crazy as well. We are continuing the context under the LF. I think we donated it as well. So the context is also staying as part of the foundation event. So we're going to be continuing to leave this wide open. Anyone's welcome to pitch anything. Come join us. Come talk about your product. You can always find our latest information on YouTube, where we kind of post the upcoming events. But we've got some great ones coming. Today's talks are going to be fantastic. We're going to be talking about code mode, and Paolo is back to talk about how he built a Svelte MCP, which I'm super excited to hear about. And then we've got some talks next week. One I'm really excited about is Fred from Alpic is going to be talking about Skybridge, this new ability to build ChatGPT/MCP apps, and very interested in seeing where that goes. And so we'll be diving into a lot of that. Then we're going to have a couple weeks off for the holidays before kicking stuff off back again in January. So come join us and come present what you're working on. All right, with all that, let's talk about today's talk. So we have 2 people with us today. Adam Jones, who is one of the brilliant engineers over at Anthropic and wrote an excellent blog a couple weeks ago about using code execution/code mode. Adam, thanks so much for joining us today. We're very excited to hear from you. You ready to get started?
I am, I think.
Brilliant. Well, let me swap my slides out and pop yours up there, and we'll get going, okay?
Awesome. Thanks for such a great introduction. Yeah, I agree. This seems like a really exciting time for MCP. I feel like it's hard to say this is an exciting time for MCP, because it always seems to be an exciting time for MCP. There's always so many exciting things happening in the community.
It does, though, feel like this is a bit of a moment. Like, I do think we're going to remember, like, okay, like that moment right around Christmas in late 25 when this thing jumped and jumped in a big way, I think.
Yeah, I'm always waiting for for it all to come crashing down or something. We're like, it ended up not working out. And so it's like every single time I get like a little bit maybe this isn't gonna work, then it we jump up just again. So it's like I think this last couple of weeks has been pretty massive in the things that have happened. So it's like it just keeps growing.
What's funny, Darren, is that I do think, just listening at the conference last night, there was definitely a feeling that this code execution specifically, this piece really is important, because the Cloudflare team gave a quick little demo, only about 5 minutes, but talked about just the token improvement they were able to see as they built. They built a pretty small sample app, but they were talking about sort of 70-80% token execution, token usage reduction with code mode on a specific type of, kind of specifically on more data intensive type of tasks. And I think that really resonates with people who are concerned about context size, are concerned about token usage, and potentially, especially some poorly built MCPs flooding lots of the, kind of really flooding the context window. So this is a talk that I'm super eager to hear. And Adam, we'll get out of your way and let you take it away. Okay.
Awesome. Yeah. Yeah. On all this, I do think we'll get that, but I think code execution maybe is that next step of like, wow, this is going to unlock way more from MCP, with hopefully server developers not having to change too much. We can talk about that later as well.
Awesome.
So let's go into that problem, that context problem. As you kind of alluded to, like when you have lots of MCP servers, lots of tools, you like get a load of like context usage. And so let's say I have the Google Docs MCP, and here it has a bunch of tools. I can get a document, create a document, update a document, all these different things. What most kind of traditional MCP clients will do, including I'll have to admit, like Claude AI and Claude Code today, is they will fetch, they'll do like a tools list call, get all the definitions, and the definitions look something like this. So if you're familiar with the MCP spec for tools, you'll have seen, you know, there's a tool name, there's a human readable title, description, input output schemas, annotations, and sometimes other kind of meta properties that you might want to inject. And so every single one of these tools has this like kind of big definition, and especially these descriptions and schemas can be particularly long, right? If you're like, JSON schema is not a very concise thing, and so if you're trying to accurately describe a powerful set of tools, often you end up like using a bunch of context on these tool definitions. And so that's a problem when you just install like one server potentially with a lot of tools, but then you go around and install like loads of servers, right? Like I personally have, I think about 20 MCP servers that I have installed a lot of the time, and so you have like 20 servers, each with say 20 tools. Now you've suddenly got 400 tool definitions, schemas, etc. in your context. And so this actually is a screenshot of Claude Code I took yesterday, where you can see that MCP tools are taking 100,000 tokens of just definitions. So this, I haven't even started anything. I've just like said hi to Claude, and I can see I've only got 3.9% of the context left of the 200,000 context, which is absurd, right? It basically means that these things are not usable when you start adding more and more MCP tools, unless you're using long context models, but then you have trade-offs against price and speed and other things there. So this is tool definition bloat. And this is like one part of the problem, right? Is just getting all these tool definitions in. But then a second problem is tool result context bloat, where let's say I have a workflow where I was talking with my sales team, and they actually do this quite a lot, where they use Gemini to transcribe their meetings, right? And you get like a nice Google Doc transcript, and you want to take that Google Doc transcript and then basically copy it into a Salesforce record to like keep a record of your customers and put it all together. So with MCP today, in classical clients, the way you would do this is your model would output something like a tool call block, and then your client would see that and then go and call the tool and then fetch the results of the tool and put the entire results of the tool into context. So if this was to get a document's content, it would return that entire, sales meeting transcript, which if it's say a 2-hour meeting, that's about say 50,000 tokens. And so now you've used 50,000 more tokens in your context. And then what you next need to do is the model needs to then call the Salesforce tool, passing in all of that transcript in. And so that's another 50,000 tokens as it writes this entire thing out. So where it writes out these notes here, it's got to write out the 50,000 tokens again. And so you've used 100,000 tokens just to copy, like basically what would take a human copy and paste quickly. A model has to like process 100,000 tokens, which is obviously going to bring costs. It's going to be slow. And if you want to do this in a whole batch, like I have a folder of my meetings over the last week, it's not going to happen in context in any sensible way. Additionally, some models are not very good at just like doing this copying, and so will mess things up by switching numbers around or like making typos, and so it also makes this more brittle. So that is not good. And so yeah, this is a recap. There's this tool definition bloat and tool result bloat. So how are we gonna fix this? And so this brings me to the presentation title, which we're like kind of looking at. Well, models are getting pretty good at writing code. I think most of us will be aware that, oh wow, like coding is actually one of their real strong suits. So why don't we get models to write code to call these MCP tools? In the same way that if I was writing a script and I might use an SDK, I can basically use an MCP server as an SDK over its tools. And so this is just one example of how you might do code execution. And I think there's like a few different ways you can put this together, but here is one that we kind of suggest, where you take each of your MCP servers and you do a tools list call, and then you code generate deterministically. So I'm not saying the model is generating code, but you have some template code that is able to generate these out of the tool definitions, and you generate some MCP like stub code. And so you might also arrange this in a hierarchical fashion. So here on the left, we have a folder tree there's a Google Drive MCP server and a Salesforce MCP server. And then each tool on those servers is a single TypeScript file. And on the right-hand side, we've got an example of one of these TypeScript files, where you can see that we've taken the input schema and turned it into this get document input. We've taken the output schema and we've got a get document response. And then the actual function itself is basically just a wrapper around something that calls up into the main MCP client that calls the MCP server. We then give models a code execution environment in which they can write code that calls this function. And when I say execution environment here, this could be, say, a Docker container that you're running. It could be, if you're running, say, Claude Code locally, it could be your machine that you already have that already has some ability to execute code. And actually, this isn't something new or something very foreign. And actually, people have been adding code execution environments to models for a long time. We've known that LLMs, particularly small ones, are not very good at, say, doing maths, right? And so you don't really trust an LLM to do maths. You get it to write some Python code that actually does the calculations, and we execute that. So if you use Claude AI today, I'm sure you'll have seen, if you ask it to do some of these mathematical calculations, it will defer to some Python execution environment. I think the same applies here. One thing to also note here is that we are using a typed language. So in this case, we're using TypeScript. This allows us to use the input and output schemas to make sure that the model's code is actually compatible with how it's wanting to call these tools. This is optional. You can use an untyped language, but we found this does improve performance because then able to self-correct by running a type checker over it first and checking that it's using the tools as expected. So I've talked about the model writing code, and so this would be the code that the model actually generates. So the model writes this code, and you can see it's going to import the Google Drive server and the Salesforce server, and it's able to store the transcript in a variable and then pass that into the update record. Similar to how if you were writing code to automate this is exactly the kind of code you would write. The model can write this code, and now suddenly the model only has to read the tool definitions it actually needs. It can look through that file tree on a virtual file system or however that's structured, look through that file tree, discover the servers that it needs, solving that tool result problem. And then when it executes, it's not storing all the results, the intermediate results in context, and it's able to pass that through directly. And then this would be code that our MCP client executes, runs, and then makes all the calls to the MCP servers with those APIs. So here I have a short demo video of this actually working in practice. So I live in London, as with most of the MCP team at Anthropic. And so you can see I've added this London buses MCP server, which when I've started up my client, it has code generated some stubs, very similar to the stubs that I've shown you before. I think the format's slightly different, but effectively the same idea. And it has two tools. It can find bus stops, and it can find bus departures at those bus stops. And so now if I ask the model, when's the next bus to Old Street Station, it's able to first search over those tools, basically get progressive disclosure as it kind of navigates that file tree, in this case with a sub-agent, to look through the tools and pull them into context. And there you see it's running a container execute tool. So rather than calling the bus tools directly, it's able to write this code. So this is the code that it's written. And you can see it's called that search bus stops tool. It's called the get bus arrivals tool. And it's also written some logic here to be able to, say, slice the results. So if it would be overloaded with, there's 100 buses coming in the next 15 minutes, which is classic for London. You get 100 buses in a couple of minutes and then none for ages. But so it's got that slice there, so it's not overloading its context. And also it can filter for the properties that it's actually irrelevant to it. So again, it's controlling what's going into its context. And so you don't get this tool overload in this context flow. The other thing it's doing at the end here is it is taking the code that it has written and turning it into a skill. And so not technically a Claude skill, but adding a markdown file would make this a formal Claude skill. But what this is doing is saying, well, I wrote the code once, I know it works, and I've composed these different tools. I've composed the search for bus stops and find the bus departures, and I can write this code and reuse it right in future. So let's see if we can go back. So next time I need to do this thing, I can use this combined tool of busarrivals.ts and just run that as a script. And I can actually import that and then compose that more. So it's kind of building out its own toolkit, its own library of things. And then you really start to get to kind of self-evolving agents, which are figuring out what they need to do, calling the tools to do that, deciding on their control flow and what goes in and out of the context. And then also being able to build up a toolkit of reusable components that get better and better as it kind of does more of these tasks and figures out, okay, right, I should be building a reusable tool for this to make my life easier in future. Yeah. So yeah, just another recap of the problems. Tool definition bloat we solved by having this explorable file tree or some kind of form of progressive disclosure about the tool definitions. We solved our tool result bloat by passing it through variables rather than through the context. But excitingly, there's some bonuses here. So we get this more powerful control flow, which I kind of alluded to earlier, where saying, the model can decide what goes into its context, but actually you get way more power. So in this case, we're using a Slack MCP server to poll a server for poll a channel for updates. And what we want here is we can import our Slack server and just keep waiting until there's something happened. So I don't know if people have used this similar thing. So for example, with GitHub, you would push a change and you want to wait for your CI to pass. What you'd find in most clients is they'll do something like sleep 60 and then check the thing and then sleep another 60 seconds and then check the thing again. All that time is using up context. It's making inference requests off to a server. It's costing you money. And also there's some trade-off between how quickly you can poll. So for example, if you just slept every 1 second, you'd be making API requests every second to your inference provider and using up context. Whereas if it can write code, it can loop over that and just do that directly. Similarly with code, I kind of also said it earlier, but as well as just looping until something happens, you can loop over a file directory. So if we think back to my Google Docs to Salesforce pipeline, if I had a whole folder, Google Drive folder of Google Docs, and I want to do this for every single one, previously it would kind of do them sequentially. It would take ages because it takes 100,000 tokens every single time it wants to do that. Whereas now it can write a simple for loop, maybe do them all in parallel with promises.all, and then runs all of them, done, and it works. The other thing this can be useful for is pre-computing conditionals. So if your model basically knows well, if this happens, then I need to call this thing. If this doesn't happen, then I need to call this. So for example, if there is some error, then I'll need to rerun CI. And if not, I should merge. It can write that as code with an if statement. And then as soon as the first condition triggers, it's able to run on to the next stuff without having to go back to the model and wait for your tokens to come back to the model and then for it to decide what to do next. You can basically pre-prepare all of that to run as one shot. And then also, as we said at the end of the demo video, is you can build a kind of skill library or library of kind of a toolkit of these composable things. And if you want, you can ask Claude to say, right, you've written me this code that you're going to execute to control these tools. We've run it and we know it works. So let's save that onto my disk as a file that I can reuse. And you can add a skill.md and ask Claude to add the skill.md so that it knows how to use this in future. And it can, again, compose and build these tools over time. And then there's an additional thing that's kind of adjacent, and it's not strictly necessary to use code execution with this, but I think this is very closely related to the progressive disclosure of tools. Is this if your user comes in and says, hey, I've got some bug, can you go look around Grafana, Datadog to understand this? If you have that tool available, it's going to be able to find that in the hierarchy, open that file up, understand how to use it, and then actually use it. But if the user doesn't have that installed, if you've got this idea of, well, you can add more tools over time or you can browse tools, you can extend that to external services as well. And so with the open source registry API spec that we released a few months ago, you can then actually search external registries and say, hey, I want to find I don't have a Grafana server, but the user has asked me to do something with Grafana. Are there Grafana MCPs available? It can find them. It can then propose to the user, hey, can we install these? And once it's installed, the client doesn't need to restart because it's just able to look at the file system on disk again and find those tools again and then start using them immediately. So to recap, I think MCP with many tools suffers from these two different types of context bloat that people often conflate, but are actually different: tool definition bloat and tool result bloat. And code execution solves both these problems and more. It can get you solutions to these context bloat problems, but also better control flow and the ability to build out a toolkit of these composed tools. We can also further extend this tool discovery concept to external MCP registries or other MCPs that you might want to install and push that to the user. And additionally, you can read more on the blog, anthropic.com/engineering/code execution with MCP. I'm sure we can probably put it in a YouTube comment as well to save people typing it in. But I think that is all from me. Thank you.
Well done, Adam. Great presentation, and thanks for diving into this in so much depth. Let me ask you kind of maybe the obvious question. So for a person who's already built an MCP, I built my MCP, the classic way. What's the lift here? Like, how much work am I doing to rewrite or adjust my MCP to leverage code execution? And do you think that are there some cases where I should do it and other cases where I shouldn't do it? Like, how do I decide if I'm a MCP author?
Yeah, good question. So I think MCP author can mean kind of one of two things, right? You can be a server author or a client author. And what this means for server devs and client devs is actually kind of different. And so I think for client devs, I would say just go out and implement code execution with MCP. It is almost strictly better in most situations if you're using the latest frontier models. I think if your users are going to be using kind of like underpowered smaller models, then potentially they will get confused with code execution. But I think also you should always keep in mind that like today's models are the worst models we are ever going to have, and they are only going to get more intelligent, and things are just going to be cheaper and faster over time. And so developing for frontier models now is probably okay, because in 6 months or so there'll be kind of like there'll be cheaper models available that can do all this. And so I would say in our internal evaluation results as well of doing this, we find, at least for Opus 4.5, it's just strictly better on all metrics. It uses less context, it's faster, it completes more tasks. So even just not even on context, but also actually achieves more things, and it's able to pass more, achieve the user's intent more frequently when it has access to code execution. For server developers, for most server developers, this means you don't actually have to change anything, because as you saw, you can just it's up to the client to code generate off your server definitions. And so if you already have a server, it will work fine with code execution. If you really want to leverage code execution well, I think structured content and input and output schemas are almost must have if you really want it to perform well. This allows the model to understand the shape of the data it's going to put in and get back much better, especially the data being returned back, and so it can compose it with other tools or do these things like type checking, etc. And the other thing I might say is perhaps also if you're considering editing existing servers, but especially creating new servers, is historically the advice has been make your MCP server use have very few tools that are quite high level, because you don't want to overload the model's context with hundreds of tools. And that you don't just want a wrap around your API. I think this has traditionally been very sensible when everyone has been implementing their clients in this traditional way. When people have tool discovery, progressive disclosure within their clients, and code execution, I think this advice is perhaps much less important. And it's actually more okay to just be a wrap around your API, which actually lowers the barrier to entry to building MCP servers quite a bit, and also can make them more powerful, because your model the model can basically understand all the different facets of your API. So you don't have to say, oh, well, we're just going to focus on the 80% of our most important API. You can actually get 100% coverage and have models do all the things that you want, say, humans to be able to do, or to be able to do it on behalf of humans.
So one logical question that happens is because I've seen this too, where it's like, oh, well, now we can just deal with all these fine-grained MCP servers, because we do see this with organizations that are like, oh, I want to create an MCP server, but they don't know how to do it. If they were to just wrap their API, then they know what to do. But if they're not going to just, if they're going to create these higher level ones, they need to understand the use cases, and then they get lost and they don't know what to do. So it's like, oh, this kind of enables, doing these fine-grained tools. But then if you take it one step further, then the question is, it's like, well, then what is MCP? What if you just, instead of using the Slack MCP that has fine-grained tools, just use the Slack TypeScript client, or, what's the difference? It's like, do you go to the step where it's like, oh, well, why do I even need the MCP servers? What is MCP, providing here? Why even,
why bother, right? If the model can just write arbitrary code and execute it, presumably it can do whatever it wants. I think this is a really good and valid question. And I think there will be some cases where this makes MCP less valuable in edge cases. So, for example, I think if you already have great ways for the model to call your API in a composable fashion, it becomes less important. So, for example, if you have like the GitHub CLI as an example of, wow, this is actually a great CLI that models really understand well because it's like well documented and people already like, it's in a lot of the training data, and it makes potentially the GitHub MCP less crucial for flows where you have access to an authenticated GitHub CLI, but that's not all flows, right? I think the case actually though for like 90% of MCP servers is actually they're still crucial because they're not like this. You don't actually already have a really nice CLI. You don't already have tons of data, tons of training data in the LLMs about your API, about your the way to call your API. And you also don't have authentication already set up for you. And so MCP gives you documentation, it gives you auth, and it also gives you a reliable implementation that you can actually rely on. Like models are good at writing code, but if your documentation is not quite there, or it's a kind of edge case API or an internal API, models are just not going to know how to do that effectively or reliably. And even if it is a well-known API, if your models are like rewriting an entire API client from scratch for every single request, or at least every single conversation, that's going to burn a bunch of tokens and spend a bunch of time like writing this thing and debugging this, etc. I will say on documentation as well, I think people often underestimate just how important documentation is and I guess context is to LLMs. And having tool definitions and input and output schemas is really crucial for models to do well. I worked in a previous organization where there was this one API, and the only way you could kind of access the API was you emailed someone called Jan, who was a lovely woman, who would send you a big PDF that was like a flattened PDF that had all the definitions of the XML shapes you had to send off to this API. And I think in a world where actually a lot of APIs look more like that than a beautiful, CLI that they're already used to, I think we're going to have MCP to wrap these to have documentation, to have auth, and a reliable implementation against them. And then the final point I'd add is the code execution is like there's a sliding scale with how much flexibility and freedom you can give it, right? Like you could just say, I'm going to let the model write whatever it wants and execute it regardless of like really what's going on in there. But you can also still sandbox it, right? If you run it in, say, a Docker container and you say, okay, you can't have any network access except like the only outbound connections you can have are through my MCP servers, you can then start to apply like enterprise governance policies. You can say, well, actually, like you're only allowed to have AI agents touch these services, or we don't want the risk of prompt injection coming in and our model exfiltrating something out to the random internet. So when you're getting untrusted data, you can only actually use these MCP servers to output things, and MCP gives you a good layer in which you can like enforce these constraints.
So another question, because I know a lot of developers are kind of concerned about like, well, doesn't this mean like it's like every time you make a tool call, AI could do something weird, like you have like, how do you test this? How do you have any degree of like confidence that it's going to work? It's not going to do something strange or whatever. It's like, what do you kind of say to that?
Yeah. I think I would like look towards the numbers and the evaluations. As I said, I think, with Opus 4.5, and I appreciate like, it is one of our most expensive models, but all these benefits I think are going to trickle down into cheaper models that can be faster and better over time. It is just like strictly better on pretty much all of our metrics. And yes, it makes mistakes sometimes, but it also gets it so much more capability that it is usually worth the benefit. The other thing to note is that like tool execution itself is also not perfect. And I'm sure anyone who's used MCP a lot knows that like sometimes models can choose the wrong tools, or they can like put in parameters wrong, etc. And so I actually don't think this is a new problem. I think models are still not 100% reliable anyways. And so yes, you're maybe giving this slightly more capability, like more direction to be unreliable, but it's like the cost benefit is such that actually overall your system as a whole is more reliable at completing tasks that your users actually want to do.
I have a question for you. So you talked about the clients adding support for this. What's the path? I mean, who's added support? Are people already adding support for this? Where are you guys at in terms of kind of adding it to Claude or Claude Code? Do you know if anyone else has added code execution support?
I know there is a PR up on Goose, I believe. They have a PR up basically about to do this thing. I know, of course, we talked about Cloudflare. They have the ability to run MCPs, I think, on workers and other things, or do code execution in sandboxes on workers. And so those are both facets to do this. Within the Anthropic messages API, we have added this capability. So I think it's branded under advanced tool calling. But if you look at our docs on the messages API, we have a guide basically of how you can give us your MCP servers, and we will run the code execution in a sandbox for you, and then send you back the requests, etc. It is not currently in Claude AI and not currently in Claude Code. And I probably can't say anything too exciting here, but it's definitely an area we're watching and would be excited, I think, to implement when ready.
I mean, there's a couple of things that kind of get like brushed over really quickly that are stumbling blocks with this approach right now. Is like the idea that basically you're generating code and the code becomes the MCP client, where most models, like most systems, are set up so that the LLM or the agent framework is the one that's calling the MCP client. So like when you get into authentication and things like that, there's like a little more things that have to kind of be done to make this work like seamlessly end to end. That like, you know, I do see that it's probably going to make sense that the providers are going to like deeply integrate this approach somehow into their products to handle all the like authentication and stuff like that.
I agree. I think the pattern that we've seen, because we have a few different prototypes, and there's also one on my github.com/donomeg/programmatic MCP prototype, I think. I can maybe post that in a bit. But the pattern that we've seen emerging is basically that agent harness is still the one that owns the connections with the MCP client, still does all the auth, and then in this code execution environment, it has a connection to the harness. So rather than it talking to MCPs directly, like the stub function underneath that, where is it? The one that looks something like this, the like call MCP tool, like this is some helper that's like goes and talks to your harness, and like the harness then goes and sends off those connections.
Yeah. So there's something that has to kind of go on kind of at that layer, because we've been looking at that too, because like we've been fooling around with the idea of basically creating an MCP server that then just does this pattern. So it's an MCP server that calls another MCP server, which then gets into the heart of a lot of these agentic identity issues and stuff, where it's like, if you have one MCP server that calls another MCP server, how do you carry through authentication and stuff? And there's actually some interesting patterns we figured out with like URL solicitations and things like that. But I'd be kind of curious to see if this kind of harness thing, this call MCP tool, kind of gets standardized in some way of like, oh, well, this is a way that I can determine that I need to make that call. So yeah, it'll be interesting. So I think like this, you know, this whole pattern is when code mode, like I think what was Cloudflare maybe was when they announced there's like, my initial reaction to it was like, it was like, it was like basically like, we're pretty much just proving that tools have to be agentic. That's kind of like, you know, it's like the solution is it's not just kind of like writing more code. It's like the only way to solve these problems of basically context bloat and all these things and whatever is like, we really have to lean into AI more. So like, because I was asking like, what do you think about like the reliability and stuff like that? Because like I see a lot of engineers push back on these things of like, no, you know, you can't, you know, like it's not going to work.
Outcomes. Yeah, you're not going to guarantee outcomes, right?
Yeah. But it's like, but I think that's the thing is like, as engineers, we have to kind of go away from where it's like, you know, if you can like reliably, you know, kind of, there's other ways to get this to predictably work, that there is already actually less reliability than you kind of already assume. So we're focusing on the right, because like I don't know that this code execution is like necessarily like the silver bullet, but this whole idea of like basically allowing AI to make more decisions on what to do and dynamically generate and whatever, it's like leaning more and more into AI where it's like dynamically determining, like as you said, like like the code flow, the fact that it can do loops and branching and stuff. Like it determines that all up, itself. So I think it's just fascinating where this stuff is going, where it's like more and more the solutions to how to make this work is actually less. It's kind of like less fancy traditional engineering code and more just patterns in AI. Like how do we create better patterns with AI to do things in kind of like predictable, eventually predictable ways.
Yeah, I agreed. I think definitely, like, because if you've already got a model, right, you can write code and then just see the results. If it throws an error, you can like iterate and get the model to fix these kind of problems.
Yeah.
I will say that like you can take this another direction, still with code execution, and actually still push towards the deterministic outputs, more with the kind of like skills thing I was alluding to at the end, where like you get your model to write code, and then like if you wanted to, you could just treat this as production code. You could add unit tests to it, you could code review it, you could like make sure this thing works, and then you start to like build up this toolkit of like more composable tools for your AI systems to use, and like even in some extreme cases, you could like get to the point where, well, like an AI agent has like looked at a whole system, understands how everything goes together, and it's like, right, I'm going to like build all this workflow, right? And like it builds a fully deterministic workflow that you just run. You no longer run the AI. It's just like a full. If you want a workflow of like, oh, copy my Google Docs from this folder to Salesforce, it like writes that code, and now you can just run it without the AI at all. And you've got this deterministic code that you can version control, test, review, etc.
I think the thing that always bugs me though is like because I think what you're saying is absolutely right, but like too many engineers will just immediately go into like, oh no, I wanted to do that, so like immediately generate, like make it deterministic, and then just always use that over and over again. But that's a very difficult problem because like you can basically look at this as it's pretty much JIT. It's like as this gets more and more evolved, you can say like, oh, having the LLM dynamically generate code and execute is like interpretation, like running in an interpreted mode. And then once you identify certain patterns are being done over and over and over again, then you can kind of solidify that and turn it into. But the problem with like solidifying it is like, it's like, how do you actually know that code that was generated was actually like correct? Like that's the one you really want to like stamp it. So you can do it out of band of like generate this skills once, but like, that only works for that one use case. Like what you would really want, and I think this is where I would say like this would go, is that you get more fancy about like, oh, generate code. And if you observe this also with AI, you get enough like, oh, this pattern is very common. And then you can actually then just kind of use AI to make sure like, okay, well, is the code good, whatever, then solidify that. And then that becomes a hot path, going forward, where it's like, oh, I can just skip the LLM. So it's like, yeah.
I feel like we could talk about this for an hour, guys. Yeah. I do think we need to wrap. Adam, thanks so much for coming on and sharing all this. It does seem like we're, the reality is this is going to happen over time as clients add capabilities, as MCPs get rewritten. I hope we'll have you come back and maybe kind of keep talking about this journey, because I do think it's pretty interesting and one that's pretty central to the success of MCPs as kind of the next year goes on. Darren?
I would throw out just like one practical thing or whatever is like, I think this is solving a lot of issues that are like, these are all very forward leaning, like for a lot of use cases, people like the tool set is already small. You don't want dynamic, so it's like, so this is still very much in the, all of this is bleeding edge, but this is in the bleeding edge of the bleeding edge. So it's like, should you adopt code execution right now? I mean, I'm not so much on the like, yeah, I think everyone should immediately use it. I think it is definitely kind of like the future, but for a lot of like pragmatic things, if like you're doing something right now, it's still a little bit too far ahead because of a lot of other issues with authentication and, so. But I think it's a very, very, I think it's basically the future, because like tools have to become agentic for all this stuff to work. So, but yeah.
Adam, thank you so much. Really appreciate you coming and joining us today.
Thank you so much. It was lovely. And we'll be pleased to come back some other time.
Awesome. Take care. All right. Our next talk is from Paolo Ricciuti. Paolo, you're joining us again. I think you're one of very few people that are second timers on the content, along with David and the MCP UI guys. So congratulations. You're obviously were so good the last time you were here. You know, we couldn't help but sort of say, come back, Paolo, quickly, bring your fantastic presentation styles. And this is going to be a fun one because you care deeply about Svelte. This is obviously your baby and something you have worked on for a long time. And you're going to share with us today the Svelte MCP and what you did to kind of build it and the journey you've been on with it. So I want to get your slides up and get out of the way because I'm super excited to hear this talk.
Yep. All right, so this is my talk, which is also called How I Taught LLMs How to Svelte. And before we begin, a small presentation is due, and I brought my personal assistant here, so I can say, like, can you help me present myself? And let's see. I absolutely can help you present yourself. You're Paolo Ricciuti, that's correct. Where do I come from? You come from Campobasso, Italy. That is correct. Where do people can find me online? People can find you on Blue Sky as paolo.ricciuti.me. That is absolutely correct. What about GitHub, though? You're absolutely right. People can also find you on GitHub as Paolo Ricciuti. What am I mostly known for? You're known for being a Svelte ambassador and a Svelte maintainer. That is absolutely correct. Where do I work? You work as a senior software engineer at Mainmatter, which is super cool because I get to work with Svelte, but also to teach Svelte, both at conference and meetups, and in my day-to-day job. Because we are a consultancy that basically specializes in Svelte, Rust, and a bunch of stuff. And we do what's called the team augmentation, which means that like we join your team, we help you hire, we help you with best practice, but for Svelte, but also with AI. We recently did a workshop on MCP, and like in general, like we teach you best practice on how to apply AI responsibly in your company. Okay, thanks. And let's move on to the presentation. And glad to help. Let me remove this conversation. Now there's RMRF. What? Okay, it's broken. It's fine. So as I mentioned, I am a Svelte maintainer, and so I love Svelte. For those that doesn't know about Svelte, this is the homepage of our website, and if we zoom in, we can see that Svelte is a UI framework that uses a compiler to let you write breathtakingly concise components that do minimal work in the browser, uses languages that you already know, HTML, CSS, and JavaScript, and it's a love letter to development. And you can see why. Like this is a Svelte 5 component, and it's basically comprised of three main blocks. It's the script tag, where you can declare variables with the $state to make that stateful. And then whatever you declare inside the script tag, you find it available in the template part, where you actually write your HTML. And you can see that like you don't have to access a variable with .value. You don't have to set it with setCount. It's just a normal JavaScript variable. Style is also an important part of the component because you can see that I don't need to use classes. I can just do button because every style tag is scoped to the component that is written on. So like it's a pretty sweet language. It's the most loved framework. But if you notice, I had to say this is a Svelte 5 component. And this is also a Svelte 5 component. But the reason why I had to specify Svelte 5 is because there was a big jump between Svelte 4 and Svelte 5 in terms of syntax. So as you can see here, we have initial and save from props. This is how you get a prop in Svelte 5. We have stateful variable count. We have a derived of count times 2, which is like derived reactive variable. Effect is to use side effect, like writing to local storage. Inspect is to log something. And then we have this on click, which in Svelte 4 looked like this. So as you can see, like the syntax is pretty different. Like you had export let instead of $props, normal variable, and this colon syntax, $color syntax for both for logging, for derived state, and for side effect. and also on::click instead of on::click. So it was a pretty big change. And who absolutely love big changes? Our future overlords, obviously. So obviously AI is not really like a heaven match with big syntax changes. Especially we released Svelte 5 basically at around the time where LLMs started to gain popularity. And so this was probably the most the usual AI experience for people that wanted to write Svelte 5 code. And there is a reason for that. So if we have this small, simple graph, this is probably the amount of Svelte 5 code that is out in the wild now, today. And this is the amount of Svelte 5 code that looks like Svelte 4 code, because Svelte 5 is completely back compatible. If to this we add the amount of actual Svelte 4 code out in the wild, because obviously not a lot of people can migrate their app, and maybe there's some old project that will never get updated. And to this, if we add the fact that Svelte 3 had basically the same syntax, you can see how LLMs can get very confused. The amount of Svelte 4-like code out in the wild is very much overweighting on the other side. And so this is the kind of code that LLMs wrote. They imported $state and $effect, which you don't have to. They used on::click instead of on::click. They passed the function to $derived instead of just passing an expression. Or for example, they used the old way of doing reactivity with stores. So even if it was a stateful variable, they still used update and $count. They did this thing, I don't know, this happened to me, but I don't know where they come from, the $. And they also did something like this, where technically this is correct Svelte 5 code, but it's not really good Svelte 5 code, because it's assigning state inside an effect where you should just use a derived. Although I have to say that I am kind of judging you, because I've seen this code in the wild, even written by human engineers. Now, the problem is that LLMs are kind of frozen in time. The moment you stop training them, that's it. You can't add more information to them. Well, more or less. You can technically add context to them. And I mean, this is not the kind of context I was talking about. This is how to add context to a Svelte component. But from context, what I mean is that you can technically instruct the LLM in your prompt on how to write Svelte 5 code. Now, I wrote a script to write this thing inside Claude, and I'm already bored even just to watch its write. You can't really do this every time you have to write a new component. And so almost 1 year ago, during Advent of Svelte, we released LLMs.txt. I think we were one of the first frameworks to do it. But basically, if you go to the Svelte docs, you can just post-append LLMs.txt, and you get something like this, which is basically a markdown file that instructs the LLM on how to use that specific part of the documentation without all the fluff of the HTML. And so LLMs could scout the word and read that file to learn how to use it. However, this was really not enough. And so we received a lot of complaints because people actually wanted to use Svelte 5 or wanted to pick Svelte over React, but just couldn't, because if you can't write good Svelte 5 code with LLMs, it will be a liability for you. Now, modern LLMs actually kind of solved already the problem. We saw since Claude 3.5, almost the new LLMs kind of solved this problem, but still a lot of people were complaining. And so, in the monthly maintainer meeting, we decided we need to do something about this. What we can do? Well, we actually launched a specific task force to try to solve the AI problem with Svelte. And obviously, there were a lot of ideas floating around, but we quickly realized that a lot of those ideas involved an MCP server. Now, I don't have to tell you what MCP stands for. It's Model Context Protocol. And in short, it's a way for MCP client like Claude Code or Claude, Codex CLI, Gemini, Copilot to talk to MCP server like Figma, Linear, GitHub, Playwright, and now even Svelte. And so like this MCP server can either act on the real world, like change, call an API, do stuff, or they can answer back, adding more context to the LLM. And this is basically what allows me to do stuff like this. So I have this open code where I asked for the slides that you are actually seeing. And these slides are actually an MCP server. So I can do, can you go to the next slide? And if everything works, yeah, it worked. Now, obviously, I will not do this a lot because that would be the most expensive auto-clicker ever. But at the time, I was a bit skeptical about it. Like, how can a framework have an MCP? Is it just to inject doc? And to be fair, like the initial implementation was exactly that. Scott Spence, which is a fellow Svelte ambassador, did exactly that, and it basically created an MCP server that served the documentation. And this is basically what most frameworks do. Like they have an MCP server that serves the documentation. Maybe they can serve like your route structure and stuff like that, but that was it. After this original attempt, Stanislav also did something similar, a bit more structured, a bit more involved in the sense that he's also added some use cases and some scenario that helped the LLM actually like build like a better understanding of Svelte 5. And this was also pretty successful. And so we actually started from his implementation, like we knew that we wanted the docs at least. But then we actually realized that most of the suggestion that we had in our task force was around the idea of having the MCP server actually read the code that the LLM generates. And we can actually do that because like Svelte is a compiler. We are pretty good at navigating the user code from a string. And so we said, maybe it could work. And so what we did is basically implement some sort of mini agentic workflow. So this is the normal agentic workflow, right? Like the user writes a prompt, he gives it to Claude, Claude generates some code and then checks the code and then generates some code and then checks again and then generates again and then checks again and then goes back to the user. With the MCP server, we basically wanted to do something a bit the same, but with an extra step. So now you ask Claude, it generates the code, it checks the code with the Svelte MCP server, and then gets back an answer and generates a new code, and then checks with the Svelte MCP server, and then once again. Now, let's actually see the code for this magic here. Now, I built this MCP server with TMCP, which is a library that I wrote, so that's why the code will look a bit different, but don't worry, like you will get it. It's very close to the official SDK. And so this is the tool that we actually think is the main protagonist of the MCP server, of the Svelte MCP server. And it's called the Svelte Autofixer. The description is very simple. Like given a Svelte component or module, returns a list of suggestions to fix any issue it has. And this tool must be used whenever the user is asking to write the Svelte component before sending the code back to the user. The schema, the input schema is actually pretty simple. You just get the code, the desired Svelte version, which because we also want you to be able to use it with Svelte 4, and the file name, just to give better output. The output schema is also very interesting because it's an object with a list of issues, a list of suggestions, and I think this is the real key. Because before I added this output schema, the LLM was calling the autofixer, getting back the suggestions, fix the suggestions, and then, okay, I guess it's fine, and just return that to the user, ignoring the fact that added some new issue while fixing the code. And with this, we basically unlock the continuous loop that I was talking about. There are some annotations, but this is the actual code. So first, I actually checked that the version is 4 or 5. I had initially this inside the tool, but Cursor was actually going mad about it. Like as soon as it tried to pass this, it tried to parse it, and it was going into loop. So I had to change it, and I had it inside the tool. But then we generate this content stuff, and then what we do is that we compile the code that the LLMs gives us, and we return every issue and warning that the compiler already returns. Then we run the autofixer on this code, and the autofixer are just basically us doing static analysis on known pattern that the LLMs get wrong, so that we can correct them. And then we literally run ESLint at runtime to use like the Svelte ESLint plugin, so that we can get even more warnings and issue with that. Obviously, if there is an error, we push the issue. But this, I think it's a very important point. If there is a JavaScript parse error, it's something that we cannot parse the component and we cannot run everything. But something that we noticed is that sometimes the LLM was writing code like this, like instead of creating an actual variable, was prepending $state instead of let or const or var. And so we can't actually explore the code if it's not compilable. But what we did was actually, okay, if there is a JavaScript error, I will return this suggestion. And I think this is very important, because the code is not actually fixing the code. It's just telling the LLM, please check if that's the case. Like, it could be a different JavaScript error, but we don't care. Like, we return the suggestion asking the LLM to please check if they're doing stuff like this. And after we do that, we basically say that if there is any issue or any suggestions, we require another tool call after you fix that. And we return everything with a structured content. And the solution looks something like this. So in this case, like, this is a small playground where we are the LLM. And we can see that if I do stuff like this, and I do import from Svelte runes, for example, and I do $state and like this, for example, you can see this is actually contacting the MCP server, and it's saying that the $sign prefix is resolved. So sometimes the LLM was just doing, okay, I will remove the $sign. And in this case, you get a lot of issues, because you're saying, like, you are using the state rune, but there is a local binding called state. $sign prefix will create a store subscription. You are importing state from Svelte runes. This is not necessary. All runes are globally available. Please remove this, import, and use $sign state directly. So, like, this kind of suggestions is basically giving more context to the LLM instead of just fixing the code, because there's just so much that we can do with static analysis. But LLMs, given context, are really good at fixing the code. And so instead of fixing the code for them, we are just saying, hey, please do this. And so this also helps us into let the LLM write good Svelte5 code. So we can say let double is equal $state count time 2, for example, and then we do $effect like this, and we do double is equal to count time 2. Now, this is technically correct Svelte5 code, but the problem is that a stateful variable double is assigned inside an effect, which is generally considered a malpractice. Consider use derived if possible. So this kind of stuff basically means that we can guide the LLM not only to write correct Svelte code, but good Svelte code. Now, obviously, it's not a silver bullet. So, like, if you have like less smart model, for example, I tried to run this with Qwen3, and it got stuck for like 30 minutes. It was just calling the autofixer. The autofixer was saying, you should fix this. And he was just ignoring the autofixer and sending back the code, basically how it was before. So, like, it's not a silver bullet. Also, this, I found it very funny, because this was a chat that I had with GPT-OSS 20 billion. I really wanted a 20 billion parameter to work. And actually, he wrote some decent Svelte 5 code, but when I had a slightly different problem, you can see that, okay, I'm stuck. Let's try another way. Okay, I'm stuck. And in the end, it's just saying, okay, I'm stuck. I'm sorry, but I'm unable to resolve the autofixer suggestion. So the model needs to be smart. But when the model actually gets it, then that's really fine. For example, I've used this Mistral with Mistral 2, I think, or Mistral 3, I can't remember. And you can see that I asked him to create a Minesweeper component, and he actually wrote like some code that was wrong Svelte 5 code. But once the scroll finish, sorry, it will take a while. You can see that now it called the autofixer 5 times in a row. And in the end, it actually got some pretty good Svelte 5 code. So this is absolutely exciting for me because I can actually write pretty good Svelte 5 code. Obviously, we also have something like resources. Like we have a pretty mature MCP server. So if you know that you need state, you can just use the state resource right in your MCP server. And this will basically give you the same LLMs.txt file that you can provide to the LLM if you know that you will need some of this documentation. We also have prompts, obviously. So like if you want, you can use this Svelte task prompt. And this will basically instruct the LLM on how to properly use the MCP server and also give the available docs directly in the prompt. Another very interesting tool that we have is this. Now, you may see these and things like this is just like gibberish. In reality, this is a Svelte playground. So this is a Minesweeper component that was built by an LLM. And you can, like, once you are building on something with the LLM, at the end, the LLM will ask you, like, do you want me to generate a Svelte playground? And it will give you this a bit admittedly huge link. And that's why we also introduced MCP UI. So like if your client supports MCP UI, you will get a Svelte editor with the result directly in your chat, which is super cool. Now to try this, you can just use https://mcp.svelte.dev/mcp for the remote version, or mpx/y-y at svelte.js/mcp to actually run it locally. We are also on the registry, and please, if you have any other issue with LLMs, open an issue because we can probably fix it quite easily. And I guess the only thing left, I don't know if it came true. It's a thanks for watching, by the way.
Oh, Paolo, that was fantastic. And really amazing journey you guys have been on. I mean, this has been a year of sort of learning how to get LLMs to work well with Svelte and building ever more powerful MCPs and ever more advanced tools to help. Let me ask you, I mean, do you feel like you're getting to the end state? Like, is this kind of, you know, you're like, this is about as good as I think we're going to get it. Like, we've kind of figured out how to do it? Or do you feel like this is something that's going to continue to improve?
I mean, we definitely want to continue improving. Obviously, like, I'm following the whole MCP spectrum pretty closely because, like, also being the author of the MCP, like, I'm really deep into the protocol. So, like, whenever there's some new toy that we can play with, we try to implement it. For example, we also definitely want to, like, convert the MCP server to a skill so that you can actually use like a cloud skill instead of the MCP if you want. So we are exploring, and obviously we are also right now we are in the process of, because one of the problems is that the documentation can be pretty verbose, and this means that, like, it will bloat your context a bit. So something that we actually did was we summarized the documentation with an LLM. Now, to actually make sure that this doesn't really affect at all, we needed a way to test the fact that it was not affecting us at all. And so we are actually building the second version of the Svelte bench, because Stanislav also built Svelte bench, which basically, like, every new model, he runs like 100 tests on a new model by itself without an MCP server to see how well it generates Svelte 5 code out of the box. But now we're actually building the version 2 of the benchmark, where we can actually decide like to run with the MCP server or not, in an agentic flow or not, we give access to test or not. And so like we are building these benchmarks so that we can actually measure how much the MCP server can have an impact on writing Svelte 5 code.
Is there who's the leader in the clubhouse right now? Like which LLM is the best for writing Svelte 5 code?
Just recently, Opus 4.5 was the first model to actually get 100% score on the original bench. Mm-hmm. In general, I would say like Sonnet was, like Claude in general was the first to be consistently good as Svelte 5 out of the box. Mm-hmm. Gemini 3 obviously also. OpenAI is always lagging a bit behind. I think that I don't know if they are doing something with their system prompt, like steering the model to actually write like React instead of Svelte. But I've also asked like Grok, Gemini, Claude, and ChatGPT, what is your favorite framework? And all of them say it's Svelte. So,
oh really?
Yeah.
That's
if
so
you want to make your LLM happy, write Svelte.
Oh yeah, maybe because it makes sense because like no, it's lying to you. It's the same way that developers lie to you. But like they're like, oh yeah, Rust is my favorite language, but they don't program in it, right? Yeah. Because it's just echoing the sentiment of like, oh yeah, Svelte is one of the most highly liked languages or whatever.
Yeah, I think that's exactly it. Like the point is like a lot of people really love writing Svelte. Yeah. Like it's the most loved framework like of all. Like it's the most used, but a lot of people want to write it, and the LLM is just picking up the sentiment.
Our product is actually built on Svelte, but so I really liked the approaches that you took because it's kind of these ideas of like basically like it's like you're writing a tool that's kind of like assisting the LLM or kind of almost kind of conversing with the LLM of like you didn't have to get the answer right, but you could make suggestions of just like it seems like you're just giving it more context or more information and helping it. You don't necessarily have to write a tool that is going to like 100% get it right. And it's kind of like this idea of like, LLMs, like in a one-shot approach, LLMs are only so good. They can only be so good. And they keep getting better and better, which is amazing. Like I'm sure that, that benchmark that you're testing is pretty much doing like one-shot tests. But if you just have this thing where it's like, well, you give it feedback and you allow it to correct itself, and then then it kind of eventually gets to the right point. And I really kind of like that model of just more agentic. And
I think like I might be biased because like we had this idea, but I think this is the right way of build every MCP server. Like obviously like MCP servers are a way also for the LLM to like modify the external world, but if you have to give something back to the LLM, you should lean hard on the fact that the LLMs are pretty smart if you know what to tell them.
Yeah, and this is also another like pet peeve of mine because I can't stand a lot of these like deterministic workflow systems that people call agents because they're like, oh, on this node you're going to call this MCP server and then you're going to get that out, and like it doesn't allow for the agentic part where it's like no. Because there's one of the things we noticed very early, because before MCP, we built this system called GPT script. Though it's whatever that it kind of mimics a lot of what MCP does. As we noticed that it was like, oh well, if the LLM screws up or like if it gives the wrong arguments or whatever, just tell it that it messed up and then it fixes itself. So like it doesn't matter so much. It's like if you just allow it to fix itself. So it's like, kind of accepting the fact that, LLMs aren't perfect, just the same way as humans aren't perfect, but we eventually get to the right place.
I think like this is probably like the engineer part of our brain that is craving for that deterministic way of doing stuff. And I think like a good like mental model is actually doing the opposite. Like yes, like you should use the deterministic part, but you should also pay attention to the fact that the undeterministic part is very smart nowadays. And so like you can guide it to actually do what you want.
Yeah, I mean, I think as engineers, we love. I mean, that's why we got into programming, and so much of us is like kind of like that very specific outcome. But programming with AI, I think is really it's almost more like dealing with people. It's how do you accomplish things with people. So if you think like, well, what would I do with a how would I interact with the person, or how would I structure a team, or whatever? It usually ends up being the better solutions for AI.
Let me ask you, Paolo, when you think about like a new, you do a lot of training, right? So you walk into a new team adopting Svelte in a company, or a new Svelte developer that's coming out of university or something, and you're saying like, okay, let me help you get your MCP stack defined. Like, because at this point, I kind of feel like if you're giving this to a developer, like, yeah, you can give them this piece, but do you need Chrome tools? Like, what is this? Like, I almost would love someone to write a blog about this, but like, what is the stack of tools you would recommend as MCPs that a new Svelte developer start with? Okay, you've got your client. What do you install? Like, what are you recommending? What are you using? What's in your workbench?
I actually don't use like a lot of MCP servers. I think like this is pretty usual. Like whenever you start understanding MCP server, you start removing a bunch of MCP server instead of adding new ones, because you know that like it's only the real important ones that matters. Obviously, like if you are dealing with Svelte, definitely use the Svelte MCP server. I think also like the usual suspect, like the Chrome DevTools and the Playwright ones are pretty good, because the moment you do front end, you probably want the LLM to have access to what is actually on the page.
Yeah.
And something that I've been like, it literally like I started using it a lot is actually the front end designer skill that Anthropic released, because it's night and day. Like usually, like I am a pretty bad designer, like in general. So like even when like I let Claude design something for me, usually it's better than me. But with the front end design skill, it really step up a notch. Like obviously, that is really only like if you have a designer at your company, you don't need that, because the designer will tell you how to do your page. But for personal projects and stuff like that, it's very like we are running the advent of Svelte even this year. Last year we did basically like a new release every day with a new feature. Like it was super fun, but also exhausting, because we had to prepare months in advance, like to get everything. Okay, we need the 24 features to release and stuff like that. And it was very fun, also for the people receiving them, obviously. But instead, this year we are doing like education. So like every day we release a new like. Every day we release a new video, an instructional video about Svelte, everything that happened in the last year. And it's helping me a lot, because like, obviously, if you are building a demo, like you don't care too much about the code and the design being in line with the rest of your product and stuff like that. But like being able to spin up like good looking demos in a snap, it's very nice.
Very cool.
So
go ahead, Darren. One more.
As much as we talk about MCP and how great MCP is, I'll be perfectly honest. In development, I don't use a single MCP server. Never.
Really?
Nope, not a single one. Like it's very, very hard for me to find specifically for development, because like Claude Code and those things are so good that like it's like the generic set of things that it already has available to it are pretty much good enough, which is because it has access to the CLI. Yeah. So I don't use a single MCP server.
I do use some of them, but I agree. Like for development, I use very few of them. Another one that I recently actually I also worked on on a similar one, which is for the AITNE initiative. AITNE stands for Ecosystem Performance, and it's basically an initiative to actually debloat the JavaScript world, because there are a lot of packages that basically just install, like there are a lot of people that just install the usual suspect, like Chalk. Pretty good, but it's a bit bloated, and you can mostly do that with Node.js nowadays.
Yeah.
And so like this ecosystem performance stuff is basically collecting a bunch of like alternatives to packages that are a bit over like bloated or old one. And we built an MCP server for that, so that when the LLM is installing a new package, it runs the install script through the MCP server and say, hey, don't use that package, use this other one.
Yeah. Well, so, but you know, so like kind of like the counter, because the thing is like, so I developed Svelte and Svelte 5 and everything, but you know, and I've done, well, again, I'm using Sonnet or Opus or whatever, because it's Claude, so I'm using but like one of the things though is like the best thing I find for a lot of these things is just linters and things like that, like the tools that are already doing the validation, because I don't necessarily, because like a lot of times, I mean, I kind of like my flow with writing code and stuff is like I just kind of get AI to spit out whatever, because I'm just trying to test things and mostly get it. And then once I'm happy with the approach, then I go and start fine tuning the code and things. And so then I'll be like, okay, we'll run the linter and stuff and fix any issues. And so I kind of go through like I start with a little bit of a slop and then I refine it. And so it's like it's not a one-shot thing. And you know, since I'm already, you know, semi-experienced on Svelte 5, I immediately know, hey, that was
it's a total, like when I'm using it, it's so different, because I really rely on Playwright and things that can kind of evaluate why is this not looking the way I want it to, because I don't write code, right? I'm not a developer.
Yeah.
So for me, I actually don't use any of the MCPs that are more sort of coding side MCPs. I use the test type MCPs. Like, why is this not look the way I want it to look? Why is the front, especially for front end stuff, because it's the behavior's not it's not working. You know, figure out why it's not working and help me go back. But with those things, someone not a developer can actually, you know, treat it more like a contractor. You know, you're really treating it like a development contractor that you've hired, and you're sort of, no, these are my 12 bugs or 15 bugs. Or 20
well, you know, and
you know, keep improving.
And I think that's kind of like the nature of, like, because when you look at MCP, it's like, you know, it's kind of something behind the scenes. It's a connector, it's a plugin or whatever, where it's like, once you build an AI product or whatever, so Claude Code is for a very specific use case of developing for already experience, you know, not already, like whatever, a developer kind of knows what they're doing, it's on the command line and everything. So it's like, once you develop the product, you know, like more MCP plugins is often like, I don't think that's like a very common use case. It's more like as you're building the product and the experience and stuff, at that time you might pull in different MCP servers to build that experience. But once you get to kind of like the end user, it's like, it's very, you know, it's kind of, it's a little, because that's what we're seeing even with like, let's say like MCP apps. MCP apps is like a like what we're doing with ChatGPT apps and things like that. It's really a subset of MCP that's for a very specific use case. And then like now that makes sense for why the developer might, or the user might bring it into the application. So it's like, you know, the MCP is still kind of a, you know, very useful more on kind of like the back end constructing the application than it is, I think, on like users just randomly picking one and throwing it in there just because it's, you know, like what is an MCP? Yeah, it's like,
all right, we promised to not go over 20 minutes. And we're so far over. This is definitely our most over episode ever. We're like an hour and 20 minutes into this conversation. Paolo, that's a great sign that you're a fun guest to have on. And honestly, Adam was great too. It was really nice to have you share.
This is good.
A good episode. Thank you everyone who joined us today and watched. As always, these will be up on YouTube if you want to share them with your friends or go rewatch bits you had to run off for. And yeah, we will be back next week before the holiday break for one more episode of The Context. And everyone, thank you again. Have a wonderful day.
Thank you for having me.
Absolutely.